So it sounds like there's some real similarities between charge and mass. Specifically, similarities between the electric force and the gravitational. Let's do some comparison to see just how similar or how different these forces are. First, let's analyze the cause of each force. Well, the electric force is caused by charged objects, whereas the gravitational force, well, it's caused by massive objects. So charge and mass are the causes of these forces. What about the effect? What kind of object feels the effect of the electric force? Well, once again, it's an object with a charge. Likewise, gravitational force is felt by objects with mass. So notice we already see one similarity. The thing that causes the force is the same as the thing that feels it. What about the force law? And by force law, I mean, what's the equation that describes these forces? Well, with gravity, we knew the force of gravity was proportional to 1 over your distance away from the massive object that's causing the force. In the case of the Earth and the Moon, R would be the separation between the two bodies. With the electrical force, it turns out the force law is almost identical. It's still proportional to 1 over r squared, so doubling the distance will decrease the force by a factor of 4. What about the direction of force? Well, for gravity, objects always attract each other. In fact, it's this attraction that allows large bodies like the Earth to form, because every little tiny chunk of rock is attracted to every other little tiny chunk of rock, and together they coalesce and form this wonderful, beautiful sphere. What about with electricity? This is where things get interesting. With electricity, the direction is not always attractive. Sometimes it's repulsive. And this one key difference is responsible for many of the fascinating aspects of electricity, which, well, we can learn about now.